يعطيكم العافية جميعا. أه قبل ما نبلش بالبرزنتيشن رح أعلن عن شغلة صغيرة. إنجاز جديد يضاف إلى مسيرة جمعية العناية بالنظر، حابب شاركها معكم. بعد ما صرت الجمعية ممثل للبنان في مجلس بصريات دول الشرق الأوسط ومجلس العالمي للبصريات بعام 2022، وانقبل كمان طلبها الانضمام بالوكالة العالمية لمكافحة العمى عام 2023. بيسعدنا انه اليوم نعلن عن انجاز جديد، وهو انه جمعية العناية بالنظر اصبحت رسميا عضو في شبكة جلوبال سبيكس، وهي شبكة عالمية بتستضيفها منظمة الصحة العالمية. بتهدف إلى دعم مبادرة WHO Specs 2030 من خلال تعزيز الوعي حول الأخطاء الانكسارية اللي هن refractive errors، وتحسين فرص الوصول إلى خدمات صحة العين وتطوير سياسات الصحية. هذا الإنجاز بيعكس التزامنا المستمر بالعمل على تطوير الرعاية البصرية وتعزيز صحة العين والصحة العامة في لبنان والمنطقة. تابعونا على وسائل التواصل الاجتماعي لمعرفة المزيد من مشاريعنا وجهودنا. Good evening, everyone, and welcome to the second series of webinars hosted by Vision Care Association in collaboration with the Eastern Mediterranean Council of Optometry. I am thrilled to welcome you to our 10th webinar in this series titled Manufacturing of Spectacle Lenses from A to Z. I am Ali, your host for today, and I am honored to introduce our speaker, Dr. Mustafa Abdu, who is an associate professor of optometry, holds a PhD in optometry from the National University of Malaysia 2014. He is the president of director of Sudani Optometry Society since 2024, former dean of the Faculty of Optometry in Visual Science in the University of Ibn Sina, Sudan, former head of the Department of Contact Lenses in the University of An-Nilayn, Sudan. He joined the Department of Optometry at the University of Jeddah, Saudi Arabia in 2019. Member of the International Contact Lens Educator اللي هي الإياكل since 2018. His research interests include cornea, keratoconus, and contact lenses. During this session, please make sure that your microphone and cameras are switched off. If you have any questions, please drop them in the chat box for the Q&A session, and the webinar will be available for replay on our YouTube channel, VCA's channel, so please don't forget to subscribe there. With that, I invite Dr. Mustafa to start your lecture. Dr. Mustafa, the floor is yours.
السلام عليكم ورحمة الله وبركاته.
عليكم السلام.
Good evening and مساء الخير كل الناس everybody. Thank you Dr. Ali for the nice introduction. Our talk of tonight will be about manufacturing of spectacle lenses from A to Z. So before to start, I would like to thank the Vision Care Association in Lebanon for this invitation. And actually, this invitation is extent of our collaboration both together. We have a deal together just to go with the profession further, inshallah. So this lecture and this talk will be the beginning of this collaboration. In this lecture, I will present and describe the basic steps in the fabrication process of ophthalmic lenses, from basic material to semi-finished lens, what we call it blanks, and then we have to move to describe the process of manufacturing the finished lens, and this is, we call it the prescribed lens. In this session, I divide it to four units or four stations. The first one about the spectacle lens materials. The second one about the manufacturing process of the blank. The third one is about the formation of the finished lens or the lens with prescription. And the last station will be about the spectacle lens fitting. So with regard to specs materials, so all of you know that it is there are two main materials that all the lenses nowadays were derived from. So the glass material and the plastic one. The basic elements of the glass material is silica, which represent almost about 65 to 80% of the whole mixture of the glasses. Besides soda, as example of soda, sodium carbonate or sulfate. Beside metallic salts and rare earth elements such as neodymium and didimium. All of the glass nowadays are derived from all these basic elements. And we know that there are three main types of glasses available in the market. The first one is crown glass. Almost 70% of this mix is silica with refractive index of 1.523. And the second one is flint glass, almost 45 to 65% is lead oxide with refractive index of 1.62. The modern one and the latest glass used in the manufacturing of specs lenses is the barium crown glass, and almost 25% to 40% from this material is barium oxide with the highest refractive index available in the glass, which represents 1.806, sorry. The second part of the material is plastic materials, and they call it also resin material or organic materials. And this material already composed of organic ingredients plus inorganic materials such as carbon, hydrogen, oxygen, nitrogen, and sulfur. And some plastic materials that we use in manufacturing for specs were derived from the planets and animal sources such as wood and cotton. We meant here the cellulose, and also from milk, casein, which is sulfuric proteins that we found in the milk. And also some gases, and I mean natural gases, will be also incorporated in the material of plastic. So it is very big and very wide range of organic and non-organic or inorganic materials that we just incorporated together to manufacture of plastic lenses. So the first plastic material used for the specs lenses is the polymethyl methacrylate, what we call it Perspex, that discovered or being used in the year 1937 to the year 1958. And the second material is a lead glycol carbonate, what we call it CR39. The third one is polycarbonate, and recently we have Trivex and high index plastic. I'm sure all of you know that the plastic material already made into process or two techniques: thermosetting plastic and thermoplastics. So the thermoplastic one is usually plastic material being soft when heated and can be remolded again. But the thermosetting plastic material is plastic materials once heated or hardened cannot be softened again. So as example of the thermoplastic material is polycarbonate, and the example for thermosetting material is the CR39. So let's move to the manufacturing process, and I want to highlight that there is two factories for designation of the specs. So the initial one will be the optic glass or optical plastic factory. This factory usually prepare the material. I mean that they mix the material for us and put it in sheets to be sent to the spectacle lens factories after they put it in a blank form. So I'm here just want to highlight that the spectacle lens factory didn't have these facilities, so the optical glass have to prepare the mixture first. This diagram shows the optical glass or plastic factory technology. So they start to have the raw material of a mixture, even glass or plastic, as we mentioned in the previous section. So they melting these mixtures in high degree of heat and with defined time. I mean, just to make sure that all the mixture were in homogeneous way. So I make refining again and again, and also keep it in high temperature for a long time, then move with the mixture to thin bath just to take out all the unnecessary bars from the mixture. And also after that, they start to gradually cooling the material and brown this material at the end to quality control, checking the refractive index of the mixture and also the homogeneity of the mixture. So after that, they have to cut it into sheets and keep it for the purpose of manufacturing. This diagram, if you see clearly, you will find all the process inside. So in the optical lens factories, I mean optical glass or plastic materials factories, so they have to prepare the blank for the manufacturers of the lenses. So after annealing, the glass or plastic is cut into small pieces and is reheated again so as to prepare it for be molded for the blank. And there are two different processes usually in this stage. The first one is casting process, and the second one is the injection process. In casting process, the liquid material is poured into a mold. I mean, what we call it in Arabic, galib, consisting of two halves, and then allow them to solidify. And in the injection one, the molten material is injected under high pressure into a mold. So both these two processes are being using still in the factories. So with regard to the chain of the process, we can see from the left, the left picture. Just let me try to use a laser pointer here. Yes, okay. So we can see the liquid material after we got the material from the mixing process. So they, as I told you, they just reheat it again and put it in blank casting in the second picture on the left. So after a while of time, or after plenty of times, they just put it in a blank area and doing blank cooling. Here it is very clear in this picture. At the end, the blank leaving the casting line, you can recognize with this arrow the blank leaving the casting lines, so to be labeled and sent to the factories. Okay. Before to send to the factories, I mean the spec factories or spectacle lens factories, the blank brought to many of process, which is generation process, just to take the rough blank side to be clean and to be smooth. Usually they work first at the anterior or what we call it the front surface of the lens, and make it very smooth and gain the power of the front surface. And also they work to softening the back surface of the blank, and they prepare the blank for being as semi-finished one. The semi-finished blank is ready to dispatch then to the spectacle lens factories with 3 items. So I will discuss this one with the next slides. So the spectacle lens factories receive the blanks and start the process of surfacing, which is, or by which we put the prescription onto the lens. I mean, until that time, in the blank, there is no power at all. So in the surfacing process, we just put the prescription onto the lens and preparing it for being cut for the frames. So there are two modes or two types of lens surfacing. One is the traditional white surfacing and the other is the digital surfacing. So there are four main steps for lens surfacing. Start with blank selection, generation, polishing and fining, and finishing the product. So I will take every step separately to discuss it very clearly. So as I mentioned earlier, the blank have three items only. We will find in the blank the material index or the name of the material that the blank produced from, and we will find the overall size or overall diameter and the base care, which is the base care for the anterior surface or anterior front surface only. Here I have a blank. I'm not sure that it is clear for you. Here I have a sample of a blank. You can see it, very huge, semi-finished lens, and with three items. As I mentioned, the refractive index of the material, the power of the front surface, and the overall size. So in the lens factories, usually they kept this blank in a store and they have to select according to the prescriptions they need to fit in. The first step is generation, which is a process by which the patient prescription is ground into the back surface of the blank. We didn't need to touch the front surface of the blank. Usually, all the operation will be conducted at the back surface of the blank. So the first step before the generation, we have to protect the lens by using protect taping, just a plastic sheet. We cover the front surface of the lens to protect it from scratch or any thing that will be harmful for the front surface of the lens. And after that, we have to block the lens with a metal blocker. Just this blocker will be the front surface at the top of the tape that we use for the protection. And this metal blocker, usually we use it to fix the lens in the generator system. So after that, we start to do the generation or roughing of the lens by removing all the unwanted bulk of the lens, and also to reduce the lens diameter, also to fix the prescription on the posterior surface. We are still in the generation process. You can see at the left here, we use a diamond knife to cut and to take all the unwanted bulk of the blank. And you can see in the right picture or the right side of the slide, the blank at the left, and the base curve here is +6 diopter with already defined overall size and refractive index. We usually work in the back surface of the lens, and we do the generation in the back curve. And here in this lens, we generated curve to -2. So the total power at the end of the finished lens is the algebraic summation of the power of the front surface and the back surface. We can remember that the front one is +6 and the back generated surface power is -2. So the accumulation is, sorry, it is minus here, but should be +4 diopter lens. After generation of the lens, we have to remove all the rough areas from the lens. So we have to brown the lens for polishing and fining process by using fining and polishing tools with the addition of polishing solution. And we use a polishing machine here, it is very clear. And after that, we have to deblock the lens from the blocker and do again the cleaning. And after that, we need to go for quality control to check and inspect the lens again. As I mentioned earlier, there are two cycles of surfacing. One is traditional one, and the other is a digital one. I'm telling you that still the traditional one being using in some countries. The traditional one using rigid polishing tool, and the outcome lens usually is not that with high quality. And the digital one using a soft polishing tools, that's why the quality of the lens is much better. So the difference between the two cycles is the polishing tool, which remain the main difference between both of them. Here, example of this cycle of the traditional surfacing. You can recognize here the selected blank, and the first process is the taping one, just to protect the anterior, the front surface of the lens. Then go for blocking, for generation and generating, and selecting the tool, which is very rigid and very tough, and for the process of polishing and fining. So the outcome is this lens. The second cycle is doing the same techniques, engraving, taping, blocking, generating, and after that they're selecting the fine tool or soft tool for polishing and doing the process of polishing. So the final outcome is well and lens with good optical quality. We're not finished. I think there is one more step. It is the coating. So as we know, there are many types of coating. There are many layers that manufacturers start to put on the top and back surface of the lens. Layers for hard coating or anti-scratch coating, layers for anti-reflection, anti-smudge, all of these are nowadays available, but I will discuss here only to the most important two of them. So start with the hard coating. Lenses that treated after the generation and polishing, yes, we need to increase the strength of the lens by prone the lens to hard coat, which is small layer of 3 to 5 microns thickness on the both surface of the lens. And this layer of scratch resistance also important to fill the gap between the lens substrate, I mean the lens original material, and the anti-reflective coat, which is the second layer, have to be as the top of the hard coating. Researches and studies showed that the quality and lifespan of anti-reflection will be better when the lens coated firstly with anti-scratch or hard coating. So this process of anti-scratch coat can be applied in two methods. The first one is a dip coating, and the second one is a spin or spinning coating. By dipping the lens or immerse the lens inside a bowl of varnish, the varnish of the anti-scratch, so the both surfaces of the lens will simultaneously being treated with the anti-scratch. So the process is very clear here. We just put the lens inside the bowl with the varnish of this coat for plenty of time, and after that we remove it out and put it in ultrasonic bath or water bath just to take the debris from it and prone the lens to some degree of heat just to make the layer of anti-scratch. The second one is usually they use the vacuum, what we call it vacuum for anti-scratch coating machine. It is very clear here, and it is digitalized. So we just have to put the lens in each surface, and we instill a drop of this varnish, and with the centrifugal force or the spinning force, the varnish will be distributed across all the surface of the lens, and then they keep it for drying, and after that we can get the lens with a hard coat. Today's some spectacle lenses, including high index lenses and lenses made from polycarbonate and Trivex, they use to build the lens with anti-scratch inside the lens. They put the varnish and the components that strengthen the lens inside the lens material. So maybe with a few times, these techniques will hide away or disappear. The second layer is by applying anti-reflective coating to the eyeglass lenses, and it is highly technical process involving vacuum deposition technology. Also, we need vacuum chamber to do the process. And you can notice here the first one after the lens substrate, the first coat is hard coating. And after that, we can do the anti-reflective coating. And after the anti-reflective, we can just do topical top coats such as anti-dust and anti-smudge blah, blah. So I want to show you the process. Here is the chamber. And we usually use a blade with different holes. You can recognize this. It reaches up to 60 holes. We can use to put 60 lens at the same time. So we just fix this blade at the roof of the vacuum. And we use to put some materials at the floor of the vacuum, some materials that we need the evaporation process to be happen when brought the vacuum to a high degree of heat or temperature. So after that, the ionic evaporation of these materials will be deposited on the surfaces of the lens. Materials that have been used include magnesium fluoride, silicon nitrate, silicon dioxide, titanium dioxide, and aluminum oxide. And I have a video, I think will be in the next slide, just will explain for you all that I discussed from the beginning. So be patient. I think it is more than 10 minutes. You will find all the steps and all the process that we discussed. Actually, I forgot to tell that I'm not affiliated by this Yash company, and I'm just using their video, but I'm not affiliated with them.
throw some light on the process of manufacturing of our products, let us now walk you through the production facility. When placing an order for your lenses at Yash Optics and Lens, the customer care executives takes all the necessary information for its production. Order received from the retailer or optician by email or over the phone is then entered accurately into the system. A moment later the order is automatically transferred to one of our prescription laboratories. The order is then processed with the help of Optotech software, which calculates the cylindrical curves and thickness as per the order requirements. And then at this point the barcode is generated, which contains all the necessary information for the prescribed lens. The order note with all the necessary details is received by the technician at the mini warehouse, where all the semi-finished lenses are kept. The technician then selects the precise lenses as per the order, and then pass it on for the next process. The semi-finished lenses, corresponding to the order, are received and verified by an operator that there is no physical damages or scratches in it and then sent to the production line. This protective film is applied to protect the front surface of the lenses from scratch or damage during the manufacturing process. An insert and a ringer position the blocker. The protected surface of lens is precautiously put in position, then a liquid alloy is poured between the insert and the lens in order to attach them together. This now makes the lens able to be handled by automated machines. Lenses are then inserted into an automatic free-form lens generator Optotech Germany machine. By scanning the barcode, this machine automatically reads cylindrical curves and thickness, thus delivers the lenses with the prescribed output. The backside of lens is surfaced by the generator, with extreme precision according to the requirements. Diamond cutting process allows the lens surfaces to be customized as per the individual's eye's need. At this stage, the surface of the lenses are still rough. Polishing is performed for several minutes to make the back surface perfectly smooth and transparent. In this polishing liquid is poured rigorously, thus a smooth and fine surface layer with required optical properties is attained. The liquid used is recycled continuously in a close loop. A laser engraves, in each progressive lens, a small identification to position the design and to identify the lenses. This process is necessary for us, the company and the retailer, for further identification. The insert is no longer required for rest of the journey of the lenses. The alloy is thus melted and recovered for reuse at the blocking stage. Now that the film is not required, it is manually taken off from the lenses. At this point, the quality control team checks the optical parameters of the lens, like its shape, size, thickness and power, to ensure it has been made as per the order. Different measures are taken to check the optical compliance of each lenses, according to the highest quality standards of the industry. Once the perfect lens is manufactured, it then moves to the coating process. At Yash Optics and Lens we have developed a space for the process which is totally air-controlled and dust-free zone. The lenses are then sorted and placed on clipping baskets. Each basket of lens goes through several baths in order for the lenses to be cleaned from all the dust particles before hard coating is applied. In this the lens passes through NOH, ROH water cleaning, easy washing, DL water cleaning, chemical garnage, and oven heating process in fully automated SEL machine from France. After the series of chemical treatments, we look for any cosmetic defects, and check the lenses according to the highest standard of the industry. The lenses are placed on rack and then in the curing oven. The temperature in the rack ensures a perfect diffusion of scratch-resistant treatment on lenses is done. Lenses are then moved to Optotech Germany, multi-coating machine. Lenses without multi-coating requirement are then finally QC checked and delivered to the retailers. Lenses are cleaned and placed on sectors. Each sectors are then installed in a vacuum chamber to apply the anti-reflective coating on the lenses. This chemical treatment is applied on each surface of the lens. As per the order requirements, lens undergoes a further enhancement. In this process, the lens is kept in arc chambers where air is removed and vacuum is created. Then a series of chemicals as per the lens material are ignited by an electric beam, which turns to gas and releases in chamber and spreads evenly on both the sides of spinning and flipping lens. Hereunder are the various coating are done as per the requirement of orders. Lustra HD, Lustra UV+, Lustra Blue+, Lustra IR+. All the above coating are done in Optotec Germany arc machine. A yellow marking stamping is applied on the front surface of the lenses. This marking allows to ensure that the lens will be edged and be adjusted as per the parameters of the patient and the frame. Then it moves to final QC checks. The lens are finally inspected for any flaws and sent for packaging and delivery. An operator performs the final verification of the lenses to ensure if there is any cosmetic compliances of anti-reflective coating. Finally, your glasses are carefully packed and shipped with proper documentation.
Okay. Sorry for cutting the video, but I think, okay, the information already with you now. So after this process, just they send the order back to the optical shops. Okay, so I already attached or shared a link at the chat box for the process of the anti-reflection. So another video is 14 minutes. Will explain for you how the anti-reflective coating are made. So let's move to the last part of the lecture because I think it took almost more than 35 minutes. So the last part of this lecture is about the lens finishing, and usually we do this in the operation room or the lab in the optical shops or the small factories or companies. So we have many steps also. The first one is the edging, and the second mounting, inspection, and dispensing. So in this finishing process, so we have to cut the lens to fit a particular shape of a frame. We usually use the cutting machine or edging machine with a variety of productions such as manual one and semi-automated edgers and full auto lens edgers. And the reason when they usually use the frame tracer inside the machine just to take over all dimension of the lens to be cut it. So all the edges have or has multiple wheels provided for gross edging, finishing, and for bevel creation. We mean by bevel creation here the edge of the lens. If we need it to be for full frames, we have to make a small thin bevel just to be inserted with the groove of the specs. And if we aim to fit it with half rimless frame, we have to make a groove inside or circum the lens just to fix the lens with the what we call it the plastic here is the rubber plastic that we just fix the lens with the half frames. So after the edging, we have to go also for polishing again, just to make sure that all the debris are out from the final lens, and we go finally for cleaning. And as you recognize from the video, every step they have to do a quality control just to inspect the lens from any deficiencies, just to overcome it or just to throw the lens, the deformed lens away and start with another one. We usually fit the lenses with heater or with heater in the plastic frames, and we fit the lenses with screws and clips in metallic frame or full frames. Sorry for running with the lecture because I know I want to save the time. So I think this is the end of our journey tonight. Before to go, I have a small quiz, maybe not related to the lecture, but just to refresh our mind with small tools that maybe most of us we know, just to refresh. And I will ask 4 questions in 2 slides, so you can answer you can drop your answer in the chat box. So in this quiz, I want to ask you, do you know these tools? Number 1 and number 2. We have to start with number 1. If you have the answer, please drop it in the chat box and let's see the answers. I will give you maybe 30 seconds. Yes, Hyatt and BD meter. The actual name is the Hyatt gauge. We usually use it for evaluation and estimation of the lens height, especially for bifocals and progressive lenses. The second one is destometer, or I think I have a okay, destometer or vertic distance gauge. We use it to measure the vertic distance from the cornea, the anterior surface of the cornea, and the back surface of the spectacle lens, which is very important also in ball lens fitting and also for bifocals. Okay, let's go to the second quiz. Second slides. Number 3. Yes, okay. Number 3. This picture give an indication of what? Practitioner view. You can see the eyes with hairlines, the subject view, just circle of light. So yes, for sure it is the pupillometer. And the last one is, and there is already answers. Yes, the last one is the coloring machine. Okay, I think I'm done. Thank you very much for listening, and here are my contacts. If you have further questions or discussion, you can just contact me through my email, through Messenger in Facebook, and through my WhatsApp number. Thank you very much.
Thank you, Dr. Mustafa, for this wonderful presentation. We have 2 questions. Okay, one of them is there any difference in the outcome between the soft and the rigid polish on the outcome of the clearance of the lens?
Sorry, come again?
Is there any difference in the outcome between the soft and the rigid polish of the lens
Yes,
for its clearance?
yes, for sure. The quality is different. So that's why more of the factories just started to use the soft tool for polishing to ensure the good quality of lenses and good quality of vision. Yes,
Okay.
sure.
Another question. Is it possible to apply the coatings in a random order, or should it be done throughout a specific order?
Yes, Should be in specific orders. As we mentioned, the coats arrange in one of the slides. We have to start with a protective coat, I mean anti-scratch coat, and after that go to anti-reflection. You can do another coating over or at the top of the anti-reflection. So all the coats will be in order and specific order, not in a random order.
Mhm. Any other question? Okay. Can any lens of any index be colored?
Yes. But maybe with different material, no. Some materials they
Will not be
prohibited.
colored.
Yes, not be
Mhm.
colored.
Okay, perfect. Again, thank you, Dr. Mustafa, and it was a pleasure having you here with us today. And thank you for everyone for attending this session. Again, this lecture will be available on our YouTube channel uh, with all of our past sessions. Have a nice evening, everyone, and thank you,
Okay, thank you
and
very
good
much.
night.